Hey guys, welcome back to the shop. So I've got a couple days ahead of me here. I'm going to be doing some more one-on-one training on our Milltronics CNC machines. Steve Schurman from Milltronics, he is going to be showing up today, and he's going to be spending about 2.5 days with me and going back over some more of the basic training on the conversational programming for both the ML16 and our 3016 TRM machine right here. The focus on this training is just to help guide me along more. Maybe we might get into a little bit more in-depth work compared to what we did the first time using our conversational programming on the machine right here. So some of you guys probably remember last summer I took some training at Saunders Machine Works on the Fusion 360, and I do intend on continuing my learning and training with Fusion 360. But to be honest with you, I've had a lot of trouble with it, really understanding it and being able to use it to the point where I get frustrated because I go into it to try to make a drawing and I can't remember what I need to do without asking somebody, and that gets frustrating. So it's been easier for me over the past several months to make a hand sketch of a part and then be able to come out here to the conversational programming and be able to do it right there. So that's what I've been focusing on. But I do plan on getting back into some Fusion 360 training. I have someone that is willing to come down and also do some one-on-one training with me with Fusion 360. I plan on getting involved with that hopefully this summer. And I would like to get better and more efficient at using CAD and CAM to be able to do this type of work. But I still want to be fluent with our programming here on the machine as well and be able to just come out to these machines and spend a few minutes to get a simple program written without having to go to the computer to draw up a program there. That's one of the benefits of these types of machines. Keep in mind, this is a tool room mill. It's not a machining center, it's a tool room mill, so it operates a little bit slower than a machining center, and it's designed for doing prototyping work, one-off parts, or short-run productions. And same thing with the ML16. I mean, sure, you can use that for high-end production if you want to, but I don't think the machine is really designed for that type of work. It's really designed for tool room work, where you're going to be doing inventing, designing, test and tuning. You know, you want to design a part for maybe a high. That's someone's car that just went by. That's what people do around here. I call it stadium level audio. But anyway, both of these machines are designed for low runs, productions, or prototyping, designing parts. And then use these machines in a tool room setting to do that type of work, and then you could go on to other machines for high production machining if that's what many shops are set up that way. Other machines doing high-end productions. And Milltronics builds plenty of those types of machines too, if you're interested in that. They have big machining centers and fast moving machines as well. But anyway, just wanted to let you know we're going to be doing some training this week. I'd like to get a little bit of video of my progress along the way, show you what projects we might work on and some of the operations that we're going to get into on the machine. And hope that whenever Steve leaves, I have a little bit of understanding of getting the programming done on the machines here. It really has been a tough learning curve for me. I won't lie. I've always been around the manual repair work, running the lathes and the mills manually, and that's what I'm fluent with, and that's what I know pretty well, I think. So it's just been difficult for me to get over here and just jump on these machines and just run with them. So that's why it's taken a little bit longer, but it's been a fun process along the way. And as I said last year when we installed these Milltronics, they decided to jump on board and set these two machines in the shop for me to learn and learn how to do CNC machining, and that's why they're here. And if I get a little bit better at it and start hopefully improving, we can certainly use these machines to our advantage to make parts and projects here for the channel and for the shop. But I got a couple here that I wanted to show you real quick. This is going to be the main focus of our CNC work. Our lathe work here. I've got these two pinion shafts from one of my viewers, and these go into some type of CNC router. I don't know the manufacturer or the specifics, but they have some routers that they use to route foam boards. the type of foam boards that you would see or purchase for toolbox drawers. And they contacted me because they cannot get these pinion gears, and they've got some that's been damaged, and wanted to replace them. So they've actually got these gears here. So you got one that's helical and you got one that's a spur gear, and there's not a lot of torque on these things right here at all. So they just wanted to machine some new shafts where we can just install these gears here and run with it. So this is going to be my practice session right here, is getting a couple of these guys made. And once I do, hopefully that'll work out pretty good. I'll send those up there to them, and they can try them out and see if they work. And if we get this solid, you know, get a proven program and a good shaft and a good part there, they said that they would actually like to order a small batch of them so that they can just have some on their shelf for future use if these get damaged again. I've got a couple of sketches here that I drew out by hand. Like I said, I just don't have the Fusion 360 figured out yet. So I got a simple sketch. These are all metric right here. So this is going to be the practice session for the lathe. And I have another project that we're going to be doing in the CNC mill as well, and we'll get to that later. I've got an adapter plate that I'd like to machine, and I think the mill here is going to be a great machine for that. So I'll give you some highlights of our training throughout this week, and hopefully we'll have some fun content to share with you from this week's work. All right, guys, so Steve's been here with me today from Milltronics, and he has been helping me with doing some more training, as I mentioned earlier. So we've been over here on the ML16 for quite a while, learning more of our conversational, and we've got these two parts that we've been running. I'm getting pretty close to the end. We finally got this thing dialed in after making a few tweaks and getting these shafts. So this one right here, this is the one that I got turned, and this one is good. This was all in sizes for the straight tooth. It's going to be that one there, minus the keyway. We'll get to that later on. All right, so now I'm working on the helical right here, and I'm turning two of those. So this is our first one. There's your first blank op 1 machines. All right, so we still got to do op 2. So I got two of these guys, so that's what we're going to work on right here. We've got it ready to go for op number 1, so I thought I would just get a little video to kind of show you guys this cut being made. I think that we'll be okay with this door here being kind of open a little bit. So we're ready to roll. Right here, cycle start. And I'm really enjoying this. You've got a really good graphic up here that's showing the tool path every time, and it's very helpful on getting in there and checking and making sure that you're proving the system before you actually even make a cut. So the green lines is your cut lines, and then the red is the rapid movements. So we're running our coolant now. I don't know if I'm going to get any spray, but we'll see if we can give you a peek right back here anyway. So we're running two tools. First tool is our CNC insert. That's considered our roughing tool. We're leaving 10 thousandths to finish it, and then once it finishes the roughing pass, it'll come in with tool number 4, which is a DNMG, and remove 10 thousandths for the finish pass there. And we're maxing out on our speed here on this 4,000 RPM as well. But it's doing really good. It's actually a little easier to show you the graphic up here of where our tool's at and our part. You see our RPM. 4,000 is a max RPM for the ML16. We've been running our Walter tools, our Walter carbide, and they are doing fantastic. They're doing a great job. We'll just go ahead and show you what this is like running the full cycle here. All right, so tool change. And we've got an optional stop set, and that's been real helpful. Hit cycle start, and now it's going to wrap it back in. Now what we ended up doing is it's making one pass to finish this out, and we've proven that out with a few extra parts. We reduced it to 2,000 RPM because we were getting a little bit of chatter on the very end right here. So we ended up reducing that, and it's leaving a beautiful finish now. And that's the, that'll be the end of op number 1. We'll open the doors. We have got a beautiful part there made. And we've been miking this guy. In fact, I'm gonna go ahead and mic this right now. I'm gonna let Steve hold the camera for me. I've got my print right here. What I was really worried about, and one of the things that I'm trying to learn, is that, you know, I do a lot of bearing journals with a lot of different parts. And so you usually, with bearing journals, you gotta be within about a half a thousandths, you know, or even less. So I was really anxious to get over here and see how close we could get these parts turned to an actual finished dimension that I want. So I'm gonna just put that right there and see what we finished our outer bearing journal here. I'm shooting for 0.591 inches, and I'm exactly 591 on the micrometer. So let me go ahead and measure the, oh, sorry about that. That's going to be 649 is what we're looking for on this journal right here. 649 on the mic. I know you guys, it's hard to see that on the GoPro, but we're on 649. And then our last journal, I'm trying to remember now, is 17, but we want 0.670. .670 on the mic. So we've only had to, I mean, whenever we were first setting it up and we were running a couple parts, so we've got, you know, we've got a couple extras right here, and I was learning, and we even had one spin on us right there because I didn't have it tight enough. So we were having to make our adjustments in the program so that we could get the tip of the tool where we wanted. So Steve's been showing me how to change the tool wear offset, right? And I actually made an adjustment of 0.2 because I was 0.2 over what I wanted to finish at, and it's got it exactly where I want to turn now. So that was after running a few parts. We noticed about 0.2 difference there, so maybe it's wear in the tool. So we brought it down 0.2, and now it's just finishing these guys right where we want it, right on size. All right, so there's 2 of these guys. Op 1 finished up, so now we're gonna flip it around, chuck it on this journal right here, and then go ahead and finish out for our Op 2. So we'll get that set up, and I'll show you guys getting it finished out. So one of the things that I'm having to do here, now if we're gonna be running a high production of these, we obviously want some kind of stop in here to make these repeatable. I plan on making a stop for our first stop that's gonna go in there so that we can just stick them in there, finish it out. But since we don't have a good way to reference that exact position every time, Steve's been showing me how you get in and you do the Z0, I'm sorry, G54 Z0, right? Okay, so that's what we're gonna do now. So I'm gonna switch this down into manual right here to control it. Now you can do this up here on the controller as well, but I like using this. I'm just gonna go ahead and rapid the tool over real close to the face of the part. You can use this joystick here, and then the rapid button brings it to the max. And then you can just use the hand wheel. And what I'm doing is just kind of eyeballing it really, really close, being very careful. Getting it up really close to the face. Now I'm gonna come over here and bring our rapid down to 5. And then I'm using a shim piece of paper. We mic this paper, and it's just over 6,000 thick. So we'll show you what we're doing here. I'm gonna come up and use this, and now I'm gonna use the hand wheel here until it catches this paper. You just gotta kind of get a feel for it. I'm going until it actually catches it, and I can feel a little pressure against the paper. Sometimes it takes a little, we're getting close, so there it is right there. It's almost trying to tear the paper. So we know we're approximately 6/1000ths off of that. So now we're going to go to our G54Z, enter Z axis position, 0.006 thousandths, and hit enter. And then now it just changed our current Z position to 6/1000ths off of that face right there. Did I do that right?
Yeah, you did.
All right, repetitious.
All right.
Got to keep doing it a little bit to remember. So now our Z position for all of our tools knows where the face of that part is. And now we can go ahead and load up our Op2. I'll go ahead and do that since you got the camera going. So we're gonna have to switch this back to auto here. And then what I want to do here is, see, now you're catching me when I'm trying to remember, is we're gonna go to run program, F7 menu. Now I want helical tooth Op2 right there, and we're gonna hit select. And it is highlighted right here so you know you're running the right program. And now we're ready to run, right?
Right.
Okay. You can hit F1 start. So we'll go ahead and get ready to fire this up. All right, so now we're ready for Op2. We'll go ahead, we got to close our chuck guard. This got me into trouble a couple times. I couldn't figure out how to turn it wouldn't work, and I'm like, what's going on? This is a chuck guard. It's got a safety switch in there. We'll go ahead and close the door. We've got Op2 loaded up, so we should be ready to go. We've already got tool one loaded up. You can bring your rapid down here so that you just make sure that everything's good to go. All right, I think everything's looking good. We got the reflection of the skylight right here on the glass, so it's even harder to see it. But I think this is a good shot. You can get the screen and a little bit of the spindle action. Max out on RPM at 4,000 now. I am running the recommended feeds and speeds from for the Walter tools with this carbide. I believe that's going to be the last roughing pass. Now it's going to come over here and change to our finish. It happens so fast I can't ever get it, so I'm going to hit cycle start to go ahead, and we're going to make one pass here to finish it out. That should be a completed part there. We've just got our, once the op is finished, we've got it set to home 00. That's why it goes out that way. Gives you clearance so you can get in here and check it. So there we go. That should be finished. I'll go ahead and get a mic and see where we finish that out at. We just finished op 2 here. So this this larger journal there is just, there's nothing that fits on it. I believe we got that one at 905 or 906. So we got it at 905 and a half. Yeah, we wrote down, this shows 23 millimeters. It's just to match this diameter of the gear right there. So that's not a critical one, but we want the journal that this gear is going to fit on to be pretty close. So we've got 591 written right there. I mic that. And we are at 591 and 5/10 right there. So we're spot on. What we wanted to finish that journal at there, we should have just a little bit of interference. So maybe we can like warm that gear up and slide it on there. So this is good. It's working out great, man. So we've moved over here to the Milltronics TRM 3016 CNC mill, and we've been proving out our little program over here now. So let me kind of show you where we're at. We've already written our program. You can see the graphics there for our keyways. So this is a really simple setup. I just used a parallel and then a vise stop up there to locate it on. And we've used our sample shafts here that were not exactly on size, but they're good test pieces there. So we've already got 3 of them cut with our 5mm by 30mm long keyway in there. And we've finally got it to the size that we want it. We're gonna go ahead and do one more. So this guy right here, I marked it with the X on the end. This is a good part as far as being on size and all of our shoulder lengths being correct. It was just turned into, it was just kind of an ugly part just because of the finish on that. So we're gonna go ahead and put this guy in there and cut it one more time just to show it being cut before we move on to, we've got our good shaft still sitting over there on that toolbox. So I have been using we've got our gauge blocks here, and I've got a gauge block stack up that was measuring it with. So we'll go ahead and put this guy in here. And I did want to mention too that I actually did not have any, I don't have any 3/16 carbide end mills for this. So I am using high speed. We've got some good 3/16 high-speed 2-fluid end mills, so we're running that, but we've got all of our feeds and speeds set according to the recommendation speeds for the high-speed steel, and it's doing really good. So just wanted to point that out. So we'll go ahead and get this guy in there and do another test cut. It's good. And one of the things that I have learned is to always remove the vise handle off it, no matter what. When you're done, always take it off. So we should be good to go now. We're still in our program from the last cut, so I'm just going to hit cycle start. I'm sorry. So Steve helped me with the programming here, and what we did was a PEX cycle to kind of remove the chips for the slot. And now we're cutting. I know it's hard to see. A little easier to follow it up there. So we've got the cutter set at 1.5 inches a minute, and our RPM set at 1100. So that seemed to be a pretty good formula for a 3/16 high-speed end mill 2-fluider. All right, now it's moving back down the back side. It'll finish it out. It should only take a couple of minutes, I believe. We got our run time up here. I think it was less than 2 minutes, and this is done. There it is. So, minute, 42 seconds, not bad at all. Should be a good key there. We've got our gauge block stack up. I've got this just slightly under 5mm. Wanted to make sure that we had a good snug key fit. So we can get it and then wiggle it down into the slot right there. So I am happy with that. We should be ready to go ahead and put the finished parts in there and get the keyways milled. So these are the 3 shafts that are all good, all on size. We've got 2 for the helical, and then we have the 1 shaft for the straight tooth. So what I'm going to do is after we finish up our training, I'm going to go ahead and make up a few more of these blanks and run them after Steve is gone, so that I have a small batch of each of them. But we'll go ahead and get the keys milled on these 3 right here. We'll try one shot in the enclosure here and see if you guys can see this. I may have the coolant lines a little bit in the way right there. One minute 42. So that shot, I think the coolant line kind of had the shot blocked. I'm going to try it one more time over here on the left side. That's our first one there. Just got to deburr it. All right, I think that shot turned out a little bit better for you. All right, we're maintaining our fit, so we should be good. All right, there was one more op that I almost forgot about, but in our helical gear, there's actually a keyway broached inside, so we did need a key milled on this end where this gear is going to be pressed on there. So I got we went ahead and duplicated the program and went in there and made our changes, and then made another work offset. We're using G54 for our first op, and then we went in there and duplicated the program and found our location, and we're using subset 1 for G54 for this keyway location there. And we just cut that one and measured it, and everything is good. So I've only got 2 of these guys right now, so I'm going to go ahead and grab the other one and go ahead and mill the other key in the shaft. Okay, so these are the 3 completed shafts that are all on size. These are good. These are good parts that we're going to run. These were the other ones that, as I was running through my training, they're either undersized or the finish isn't good. And this is just part of my practicing and learning. So there was a couple of them that I didn't hit the size that I want. We were like, you know, a half a thou or even 1 thou under when we first started turning it before we were adjusting our tools. So there was a couple of them that we just skint down a little bit more, so that we were trying to get the tip of the tool exactly where we wanted, adjusting the tool wear compensation. So anyway, just practice pieces right there. We had this one, I don't know how it did that, but it actually spun, and I recall tightening it down, but apparently I did not. You can see we've got, this is turned down a little too small there. So just part of my training, part of my learning. Same thing with the keyways. Since these were bad parts anyway, we just used that to make sure that we had our keyways, and it just provided some practice, you know, sort of repetition. All right, so I'm going to end up turning 2 more of these and 1 more of this guy right there, so that we have 2 of the straight gear and then 4 of the helical gear there. All right, so there's just a little bit better shot of what our parts look like finished out. I've already got the keyways deburred. What I like to use sometimes for that is the Noga deburr tool to get in there and actually deburr the top of that key. The high-speed end mills tend to want to leave a little bit more of a burr there versus a good sharp carbide end mill. But I plan on getting me some of the carbide end mills that I need to get these keyways done, because I imagine they're going to end up wanting another batch of these machined later once they test them and make sure they're going to be good to go. But anyway, I just wanted to kind of give you a little closer shot. These are all on size. All of our shoulder lengths are perfectly on size from both ends. All our diameters are exactly where we want, so that it's going to give it the proper interference fit for the bearing, so they don't just slide on there. All right, our keys are on size, so all good to go. There's the other one, and then the last one here. So this has been, these parts right here have actually provided some pretty good training with our conversational programming. All right, guys, I think this is going to wrap up this video of my training session working on these little pinion shafts right here. I got to thank Steve Schurman for coming down here and helping me and being so patient with me. You know, I feel like personally I've been having kind of a tough time picking up CNC machining in general, as far as the CAD and CAM and the programming. But as I said before, I have really been enjoying learning the Milltronics conversational programming on these machines. And the more that I practice with these guys and the more projects and jobs that I get in here, I'm starting to get a little bit better with it. I'm starting to remember more and more about what Steve has taught me on how to find things. It's really remembering where to go into the software and to select what it is that you're wanting to do. That's sort of the big thing. And the more times you do it, the better you're going to remember that. And I'm sure a lot of you guys watching are already very knowledgeable on this kind of stuff, and you've been there and you've experienced it and you know what I'm talking about. When you first jump into it, I say it like this, it's almost like learning a new language. When you're you know, in your 40s and you've only spoken one language your whole life, and then all of a sudden you have to learn a new language, it's tough. And that's what I feel like. It's like learning a new language, but it's really about learning the software and learning how to navigate it to make it do exactly what you want it to do. But once you have someone like Steve that is standing there next to you and you get stumped and you're not sure what to do next, and he tells you and he shows to you and says, select this, and it's like, bam, there it is. Now that makes more sense. And then once you go through the whole program and you see the machine finish a part like that you drew on the computer, it is very fulfilling and it's satisfying, especially whenever you can get one on size like this. So thank you again, Steve, and hope to work with you again. We talked about maybe sometime later in the year, Steve come down here again for another couple days, and maybe we work on some more advanced features or some more advanced programming anyway for the CNC machines. So that's going to be it. I'm going to finish out the other shafts that I want to do to finish this small little batch off camera. Now that we have the program saved and proven, we should be able to knock out a few more of these no problem without Steve being here next to me to guide me and make sure I'm not screwing anything up. But I feel confident I can knock out a few more of these, and hopefully a few more in the future if they decide that they want to purchase a batch of these for their CNC machines. These are going to some CNC routers that route foam boards for toolbox drawers. So anyway, hope you guys enjoyed watching this little journey of some of my training, and I already have some more projects sitting right over here that I'm planning on showing with you probably the next video or two. We're going to be getting back over here on the CNC mill and doing some machining of some steel plates to make some adapter plates. So I hope you come back and watch that project as well, and we'll see you guys again very soon.